Hello Sleepy Science subscribers, welcome to the channel. Please do not forget to like and subscribe so more people can benefit from these calming journeys. Tonight we begin a gentle and thoughtful exploration of a question that has puzzled scientists, philosophers, and dreamers for centuries: why time moves forward and never backward. As you relax and settle into a comfortable position, allow your mind to drift through the quiet landscape of physics, where the flow of time is shaped by deep natural laws rather than simple intuition. Time feels like a steady river that carries us from past to future. We remember what has already happened, but cannot see what has not yet occurred. This one-way movement is called the arrow of time. Although it seems obvious in daily life, its origin is surprisingly complex. Many of the fundamental laws of physics, such as Newton's equations, or the equations governing electric and magnetic fields, work the same whether time flows forward or backward. If you reverse the motion of planets or the paths of particles, these laws would still make sense. Yet the universe clearly chooses one direction. This difference between symmetrical laws and directional experience forms the heart of the mystery. One of the key ideas that helps explain the arrow of time is entropy, a measure of disorder described by the second law of thermodynamics. According to this principle, entropy tends to increase over time. A cup of hot coffee cools, not the other way around. Smoke disperses into the air rather than collecting itself back into a neat cloud. Ice melts in a warm room. These processes show that systems naturally evolve from low entropy to high entropy states. Because entropy increases in one direction, the flow of time appears to follow the same direction. The arrow of entropy becomes the arrow of time. The early universe provides crucial insight into this behavior. After the Big Bang, the universe was extremely hot, but surprisingly smooth. Matter and energy were distributed in a uniform way, creating a highly ordered low entropy state. As the universe expanded and cooled, small irregularities formed stars, galaxies, and planets. Over billions of years, entropy increased as structure emerged and energy spread out. This gradual rise in entropy gives time its forward direction. If the early universe had been chaotic instead of smooth, the arrow of time might not exist as we experience it. Another layer of understanding comes from the behavior of memory and information. We remember the past because physical traces remain, such as footprints in sand or signals stored in neural patterns. The future cannot be remembered because it has no physical imprint yet. Information naturally accumulates in one direction, which aligns with the growth of entropy. Memory flows the same way time does, creating a psychological arrow that matches the physical arrow. Quantum mechanics introduces additional subtleties. On small scales, particles behave probabilistically and events become defined only when they are measured or observed. Yet even in quantum systems, entropy tends to grow when many particles interact. The microscopic uncertainty of quantum states does not break the direction of time. Instead, it reinforces the idea that time progresses from more ordered situations to less ordered ones. As we move gently into this topic, it becomes clear that time's forward flow is not a simple illusion. It arises from deep thermodynamic and cosmological principles. Entropy increases. Information accumulates. The universe expands. These processes together create the feeling of time moving always forward. In the next parts, we will explore how gravity, space-time geometry, quantum fields, and human perception all contribute to this mysterious and calming flow. The question of why time moves forward becomes even more intriguing when we examine the structure of space-time itself. According to Einstein's theory of relativity, time is not separate from space. Instead, time and space form a single smooth fabric known as space-time. Objects with mass bend this fabric, creating the effect we call gravity. Yet even within this curved structure, the laws of relativity do not select a preferred direction for time. They allow time to be reversed mathematically without breaking the equations. This symmetry deepens the mystery. because our physical experience clearly favors a single direction from past to future. To understand why this apparent conflict exists, we can look at how matter behaves when many particles interact. A single particle in motion can be reversed without contradiction. But when countless atoms and molecules combine, the behavior becomes statistical rather than precise. This is where thermodynamics enters again, revealing a natural tendency for systems to evolve toward more probable states. Low entropy configurations are extremely rare and fragile, while high entropy configurations are common. Time moves forward because the universe constantly shifts from improbable arrangements toward more probable ones. The direction of increasing probability becomes the direction of time. Gravity adds another layer to this picture. While entropy describes disorder on small scales, gravity shapes structures on cosmic scales. When matter clumps together under gravity, it may seem like entropy is decreasing because structure is forming. Yet, gravitational entropy behaves differently. Large, diffuse clouds of gas actually represent low gravitational entropy, while concentrated structures like stars and black holes represent higher gravitational entropy. When the universe evolves under gravity, it is still following the rule of increasing entropy, even while creating new structures. This means the arrow of time is woven into cosmic evolution as well as everyday processes. The formation of black holes illustrates this idea in a dramatic way. Black holes contain enormous entropy, far greater than any ordinary object of similar size. When a star collapses into a black hole, entropy increases sharply. Stephen Hawking's work showed that black holes also radiate energy over vast timescales through the process known as Hawking radiation. This radiation increases entropy even further. Through this mechanism, black holes become powerful engines of thermodynamic change, reinforcing the forward direction of time on cosmic scales. Another aspect of time's arrow concerns causality, the principle that causes come before their effects. We push a ball and it rolls forward. A match strikes and flame appears. In a reverse timeline, effects would precede causes, which contradicts how information travels in physical systems. Information spreads outward in time, but not backward. This one-way transmission aligns with entropy's direction, supporting the idea that the arrow of causality is another expression of the arrow of time. When information flows in one direction, time flows in the same direction. Quantum mechanics also offers subtle reinforcement. While the laws governing individual particles can be time reversible, measurement and decoherence introduce asymmetry. When quantum particles interact with their environment, their states become entangled and information spreads outward. This process is difficult to undo because it involves countless microscopic degrees of freedom. The spreading of quantum information gives rise to an effective arrow of time, even though the underlying equations remain symmetric. This process, often discussed in the context of the measurement problem, shows how time's direction can emerge naturally from quantum behavior. Human perception provides another layer of insight. Our minds create a flow of experience by storing memories of earlier events and projecting forward expectations. We sense time moving forward because our brains encode information in one direction. The neural structure of memory formation requires entropy to increase as signals spread and patterns strengthen. This cognitive arrow does not define time's direction, but it aligns with the thermodynamic arrow. Our perception simply follows the physical processes that govern the brain. The universe's expansion is also tied to time's direction. As space expands, energy becomes more diluted. Radiation cools. Structures spread apart. These trends reinforce the increase of entropy on cosmic scales. Because the early universe was low entropy, and the current universe is higher entropy, the direction of expansion matches the direction of time. If the universe were to contract, theories suggest that the arrow of time might change under certain conditions, although this remains speculative. Through these layers of physics and perception, a unified picture emerges. Time's forward flow is not imposed externally. It arises naturally from the increase of entropy, the spreading of information, the behavior of gravity, and the expansion of space. Each mechanism reinforces the others. Together, they create the familiar sense of movement from past toward future. The arrow of time is not a simple feature of the universe. It is a deep expression of how physical law and cosmic history intertwine, guiding the gentle flow of events in one direction. To understand why time flows forward, it is helpful to explore how the universe handles information, structure, and the evolution of physical processes over enormous timescales. One of the most powerful ideas in modern physics is that the arrow of time is deeply connected to how information is arranged in the universe. When a system evolves, information spreads out, becomes less organized, and becomes harder to reconstruct. This spreading is a form of entropy growth. When information disperses, it becomes impossible to recover previous states perfectly. This irreversibility underlines the forward movement of time. Consider a simple example. When a drop of ink falls into clear water, it spreads until the entire water becomes lightly colored. Each particle of ink mixes with countless water molecules. In principle, physics allows us to reverse every particle's motion and restore the drop. In practice, the information becomes so widely distributed that reversing it is impossible. This impossibility creates an arrow. Systems start in states that are easier to define and move towards states that are harder to describe. Time aligns with this movement from organized information to dispersed information. Another perspective comes from the dynamics of complexity. Early in the universe, matter was distributed almost uniformly. As gravity acted on slight imperfections, complex structures emerged. Stars, galaxies, and planets formed through gravitational collapse. Complexity increased for billions of years. Yet, although complexity appears to grow, this growth still corresponds to increasing entropy because gravitational collapse leads to states with greater gravitational disorder. The formation of galaxies therefore supports the arrow of time even though structure is being created. The universe moves towards states that are statistically favored given its expanding nature. This relationship between structure and entropy can be seen clearly in black holes. A black hole represents one of the highest entropy objects in the universe. Its entropy is proportional to the area of its event horizon. When matter falls into a black hole, the entropy of the universe increases dramatically. Because nothing that enters a black hole can escape in its original form, the loss of information creates a powerful asymmetry in time. Hawking radiation eventually leaks energy back into space, yet the structure of the outgoing radiation does not allow the original details to be reconstructed. This irreversible transformation strongly reinforces time's direction. We can also approach the arrow of time through cosmology. The expansion of the universe is not just a background process. It influences the entire thermodynamic landscape. As the universe expands, energy spreads out and densities fall. Space becomes increasingly uniform. This uniformity supports the growth of entropy and the one-way direction of time. If the universe had begun in a fully random state, the arrow of time would be weak or non-existent. However, the early universe was surprisingly smooth. This low entropy beginning sets the stage for everything that follows. Time flows forward because the universe started in a condition that allowed entropy to grow. This perspective raises an important question. Why was the early universe low entropy in the first place? Physicists such as Roger Penrose have explored this question deeply. Penrose proposed that at the Big Bang, the gravitational field had an extremely organized structure. This organization created a boundary condition that allowed entropy to increase afterward. Without such a special initial state, time might behave very differently. Penrose calls this the Weyl curvature hypothesis, suggesting that the early universe had nearly zero gravitational entropy. This created the conditions necessary for the arrow of time to emerge. Another angle involves the behavior of quantum states in expanding space. In quantum mechanics, systems evolve according to the Schrödinger equation, which is reversible. Yet when quantum systems interact with their surroundings, they lose coherence, a process called decoherence. Decoherence is effectively one way, because reconstructing the original quantum state requires controlling enormous amounts of information. As particles spread out and interactive coherence increases and time's arrow strengthens, the growth of decoherence mirrors the growth of entropy, forming another layer of temporal direction. Time's flow is also tied to boundary conditions. In physics, a boundary condition is a rule defining a system's behavior at its edges. The universe appears to have a clear boundary in the past, the Big Bang, but no known boundary in the future. This asymmetry creates a situation where processes can begin in an organized state and evolve toward disorganized states. If time had a symmetric boundary in the future, the arrow might run differently. Because we appear to exist between a low entropy beginning and a high entropy future, the direction of time becomes unavoidable. Human experience of time fits naturally within this physical structure. Memory, thought, emotion, and sensation all depend on microscopic processes in the brain that produce irreversible changes. When neurons fire and form connections, they alter physical structures. These changes accumulate in one direction. We cannot modify our brains to remember the future because physical traces of future events do not exist. Memory emerges from entropy increasing patterns in the brain, and therefore aligns with the physical arrow of time, rather than defining it. Taken together, these perspectives reveal that time's forward motion emerges from the interplay of entropy, information spreading, gravitational structure, decoherence, and cosmological boundary conditions. Each of these mechanisms supports the others. As they combine, they create a smooth and consistent flow from past to future. This flow does not come from one specific law, but from the collective behavior of the universe across scales. It is the gentle and inevitable consequence of how reality organizes itself. In the vast calm of the universe, where silent light drifts through endless space, the flow of time feels like a gentle current guiding every particle, every cloud, and every star. When we imagine the cosmos, not as a chaotic storm, but as a quiet ocean, filled with soft movements, the arrow of time becomes easier to sense. In this dreamlike landscape, dust clouds stretch like cotton across the darkness and galaxies glide past each other like slow-moving lanterns carried by a cosmic wind. Beneath all this beauty, the laws of physics continue their patient work, shaping the forward motion of time. One of the most soothing ways to understand time's direction is to imagine the universe as a vast room of cooling light. In the early moments after the Big Bang, the universe glowed intensely with smooth, uniform brightness. As the cosmos expanded, that light softened, stretching into longer wavelengths, until it became a faint whisper dancing across the cosmic background. This slow cooling is a form of increasing entropy, and the gentle fading of radiation reflects the forward movement of time. Just as warm air in a quiet room slowly cools without reversing, the universe follows a path from brightness to softness, from order to gentle diffusion. The same calm motion appears in the way matter drifts through space. A cloud of gas collapsing under gravity may first seem like a reversal of entropy, yet gravity reshapes structure in a way that still favors higher entropy states. Stars ignite like tiny candles in the silence, then fade as fuel runs out, leaving behind peaceful embers such as white dwarfs and neutron stars. These remnants glow softly at first, then sink gradually into darkness. Their quiet, cooling mirrors the universe's long exhale, guiding time forward through stages of ever deeper stillness. Even in regions where matter is sparse, light continues to travel silently. Photons stretch into delicate threads that glide through space without resistance. As they move, their energy thins and their color fades. In this slow fading, we find another expression of the arrow of time. Light cannot gather itself back into the brilliant glow it once had. Instead, it becomes part of the soft cosmic background, a calm reminder of earlier eras. The peaceful way light disperses across expanding space is one reason time cannot reverse. Quantum processes, too, carry this dreamlike quality. Particles shimmer with uncertainty, appearing and vanishing in ways that resemble faint ripples on a still pond. When these particles interact with their surroundings, they lose coherence in one direction, spreading information outward like a breath in cold air. This spreading is irreversible. The delicate patterns of quantum states cannot be gathered back into their original sharp form. Coherence gives time a subtle push, aligning the microscopic world with the growing entropy of the universe. Gravity also shapes the arrow of time in quiet and elegant ways. When galaxies form, they spiral together slowly like enormous drifting leaves, creating patterns that are beautiful but unstable. Over billions of years, these structures relax. Stars scatter, gas spreads. Black holes form at the centers and gather material until they become dense points of darkness surrounded by halos of faint light. These processes move forward because the universe constantly seeks more probable states, expanding into arrangements that reflect growing entropy. Even the collapse of a star into a black hole increases entropy dramatically. This increase ensures that time continues in a single direction. The cosmic horizon introduces another, gentle boundary. As space expands, galaxies slip beyond visibility, their light stretched until it can no longer reach us. In this slow disappearing act, we see a soft metaphor for time itself. The past remains visible for a while, like fading stars on the edge of memory. But future light has not yet arrived. The universe becomes a stage illuminated by the soft glow of what has already happened while the future waits in silent darkness. Human perception aligns with this cosmic rhythm. Our memories form like footprints in the sand, impressions left behind by experiences that have already occurred. We cannot step into the future because no trace has been made there. Our thoughts drift with the same directionality as entropy, moving from stored impressions toward open possibilities. The brain itself, a network of delicate signals and electric pulses, follows physical processes that leave permanent marks. These marks create a forward flow mirroring the universe's own progression. In this gentle and expansive picture, time is not a force pushing events forward, but a quiet consequence of the universe's tendency to spread energy, disperse information, and move toward states of deeper stillness. The arrow of time is woven into every drifting photon, every cooling star, every spreading cloud of cosmic dust. It is written into the soft geometry of spacetime and reflected in the peaceful expansion of the universe. As we drift further into this topic, we will explore how these patterns connect across scales, revealing a deeper harmony between physical law and the quiet flow of time. As we continue drifting through the quiet landscape of the universe, it becomes easier to imagine time not as a strict mechanical flow, but as a gentle breeze moving through a peaceful cosmic valley. Everywhere we look, we find subtle patterns that reveal why time carries everything forward. In the silent backdrop of space, delicate threads of light stretch across darkness. Dust clouds float like soft pillows, slowly unfolding into new shapes. These calm movements express the universe's tendency to shift from ordered beginnings to more relaxed and expansive states. The arrow of time is written into this slow unwinding, as if the cosmos itself were exhaling across billions of years. A helpful way to picture this is to imagine a vast fog of particles drifting in a cosmic sea. At first, the fog may be dense and structured, but as time passes, it spreads outward. Each particle moves in its own direction, leaving behind the organized pattern it once shared. This spreading is entropy in motion. It is the reason a warm cup cools, a star fades, and a memory becomes something that can only be held in the mind's past. Entropy provides the directionality that time follows, a soft but unbreakable rule guiding the universe towards states that are easier to reach and more diffuse. When we zoom into the smallest scales, quantum processes add their own quiet rhythm. Particles shimmer with uncertainty, their positions and momenta forming patterns that shift like gentle ripples on dark water. When many particles interact, their combined states expand into countless possibilities, making it impossible to reverse their paths without perfect precision. This loss of perfect reversibility reflects the flow of time. Quantum states spread like soft light falling onto a surface, never gathering back into the exact shape they once held. Decoherence, the spreading of quantum information into the environment, is another expression of time's gentle but persistent push. Gravity shapes the arrow of time in a different but equally calming way. Imagine a cloud of dust floating through space, illuminated by the faint glow of distant stars. Gravity slowly gathers the dust, pulling it inward until it becomes a star or planet. Yet even as gravity creates structure, it also increases gravitational entropy. A collapsed star forming a black hole represents one of the highest entropy states in nature. Black holes are like deep wells in the fabric of spacetime, silent and heavy, with event horizons that glow faintly through Hawking radiation. They serve as engines of entropy, reinforcing time's direction as they slowly evaporate over unimaginable ages. Another soothing perspective comes from the expansion of space itself. As the universe expands, galaxies drift apart like lanterns slowly carried by a gentle current. The distances between them grow larger, and the light they emit stretches into faint red glows. Eventually, this light becomes so soft and long that it blends into the quiet background. This stretching of light, this cooling of radiation, continues endlessly as the universe relaxes further. Expansion makes reversibility impossible. Nothing can return to the tight, bright state that once existed. The universe opens wider and wider, and time follows this widening path. Cosmic horizons also shape our sense of temporal direction. As space expands, regions drift beyond the limit of what light can reach. These distant galaxies fade into silent darkness, leaving behind a sky that grows emptier with time. The horizon acts like a slowly closing curtain, hiding what was once visible. This steady disappearance aligns with the idea that time pushes the universe forward, leaving the past illuminated and the future hidden. We stand between what we can remember and what we cannot yet know, held in the flow of entropy and expansion. Human consciousness fits naturally within this tapestry. Memories form as delicate traces in the brain, shaped by the spreading of signals and the strengthening of neural patterns. These traces cannot reverse themselves. They create impressions that accumulate only in one direction. Our minds drift gently through moments, always facing what comes next, never returning to what has already passed. This psychological arrow echoes the physical arrow, as if the universe and the mind agreed to move together through time's calm river. When all these layers combine, a picture emerges of a universe that glides smoothly toward relaxation. Entropy increases like a soft, spreading cloud. Light stretches into long, peaceful waves. Structures cool and quiet. Quantum information disperses gently. Gravity forms and dissolves patterns. Space-time expands with a slow, rhythmic breath. Every movement reflects a natural, graceful transition from organized beginnings to tranquil futures. The forward flow of time is not a rigid rule, but the gentle unfolding of cosmic patterns, guiding the universe into deeper stillness with each passing moment. As we drift deeper into the nature of time, the universe begins to resemble a vast dreamscape, a place where soft light floats through an endless ocean of silence. In this quiet expanse, galaxies become distant lanterns, suspended in slow motion, their spiral arms gently unraveling like strands of silk in a calm breeze. Dust clouds stretch across the void in pale cotton-like shapes. Stars shimmer faintly and fade like memories dissolving into sleep. Within this gentle cosmic scene, the forward flow of time becomes easier to imagine as a natural and peaceful unfolding of the universe's own story. One of the most soothing perspectives on time's direction comes from considering how energy spreads. Imagine a small pool of warm light drifting into a cooler region. The warmth slowly dissolves outward until it becomes smooth and even. This spreading cannot reverse on its own. It is a quiet motion toward balance, as gentle as ripples smoothing out on a still pond. The universe behaves the same way. Energy flows from concentrated regions into open space. Order softens into gentler arrangements. These slow transitions create the arrow of time, not through force, but through the natural desire of the universe to relax into wider, calmer states. If we turn our focus to gravity, we find another peaceful guide for time. Gravity gathers matter into soft spirals and drifting clouds. Over billions of years, these structures rise and fall. A star forms when floating gas gently compresses, glows for a time, and then cools into a silent ember. Even after collapse into a dense remnant, the process continues in a single direction. The collapse of matter into a black hole represents an enormous rise in entropy. The black hole's event horizon glows with the faintest quantum radiation, like a delicate halo shining in the night. The evaporation of a black hole over vast ages is irreversible. This gentle release marks time's direction through one of the universe's deepest processes. Light itself carries the same calming signature. A photon leaving a star begins its journey bright and energetic, yet as it travels through expanding space, its wavelength stretches. The color softens, the energy thins. Over unimaginable distances, the light fades until it becomes a long, whisper-like wave gliding through the cosmic darkness. This stretching cannot be undone because the space it travels through continues to widen. The photon cannot regain its former energy. Its softening glow is another signpost of time flowing forward, written in the faint language of drifting light. Quantum behavior adds a subtle shimmer to this picture. At the smallest scales, particles flicker with uncertainty, appearing and fading like sparks within a slow breathing field. When a particle interacts with its environment, its delicate quantum state spreads outward. This spreading, called decoherence, is one way. The original crisp pattern dissolves into countless tiny interactions. Undoing it would require aligning every particle in the universe in the exact configuration it once held. The impossibility of this reversal gives time a microscopic direction, like a faint current beneath the surface of spacetime that gently pulls everything forward. Another layer of understanding comes from the universe's expansion. Space stretches like a soft fabric being drawn outward. Galaxies drift apart, their motion slow and graceful, as if carried by a silent tide. The expansion creates more room for entropy to grow, more space for energy to spread, more calmness for the universe to settle into. Because the expansion is continuous and irreversible, the arrow of time flows with it. We cannot gather the universe back into its earlier compact state. The smooth expansion carries time onward in a gentle, inevitable motion. Our perception reflects these cosmic rhythms. Every thought, every memory, every heartbeat marks a small flow of entropy. The mind stores experiences in one direction, leaving trails of impressions that outline where we have been. Memory is like faint starlight lingering behind us, while the future remains a quiet darkness waiting for new patterns to form. Consciousness moves in the same direction as the universe, following the calm path created by spreading energy and softening structure. When we look at the universe through these soothing perspectives, time stops feeling like a rigid ticking mechanism and becomes instead a natural drift. Energy spreads, light stretches, structures cool, quantum states disperse, space widens. Each motion moves from tighter beginnings towards softer futures. It is as though the cosmos is slowly relaxing, releasing tension that has existed since its earliest moments. Time's arrow is not a harsh rule, but the gentle unfolding of these patterns. As we continue exploring this topic, we will see even more ways the universe guides its own calm flow, revealing how deeply the arrow of time is woven into the soft fabric of space-time itself. As we drift further into the mystery of time, the universe begins to feel like a vast, dream-soaked canvas where every motion unfolds with patient elegance. In this gentle expanse, soft streams of light move through a calm ocean of darkness, stretching into delicate threads that shimmer briefly before fading into the horizon. Dust clouds drift like pale cotton suspended in silence, their shapes slowly changing as gravity guides them into new forms. And behind all of this, the arrow of time flows quietly, shaping every transformation with the lightest touch. One of the most peaceful ways to imagine time's forward motion is to picture the universe as a giant landscape where everything slowly settles. At the beginning, the cosmos was dense and bright, like a glowing mist packed with energy. Over billions of years, this glow has softened. Matter has spread. Light has stretched. Patterns have relaxed. Time moves forward because the universe is gradually smoothing itself out, letting tension release into the quiet fabric of space-time. This movement toward calmness is not forced but natural, like a sigh escaping from deep within the cosmos. Entropy, the measure of disorder, is at the heart of this settling process. Entropy increases because it is easier for energy to spread out than to remain tightly organized. Think of a handful of sand falling onto a smooth surface. The grains scatter naturally into a gentle spread. They will not gather themselves back into your hand. The same principle plays out across galaxies. Stars release their warmth into space. Gas diffuses. Radiation drifts outward. Each motion allows time to take another soft step forward. Time follows the path of increasing calmness, where energy becomes more evenly shared across the universe. Gravity's role in this dreamlike evolution is both subtle and powerful. Although gravity can gather matter into stars and galaxies, these processes still support the arrow of time. A cloud of dust collapsing under its own weight moves into a more probable state as gravitational entropy rises. The collapse may appear like gaining order, but on a cosmic scale, it releases energy and increases disorder elsewhere. A star shines because gravity compressed it. When it exhausts its fuel, it fades into a quiet remnant. These cycles all move in one direction, like waves gently settling onto a shore. Black holes deepen this direction even further. They sit in the darkness like silent wells wrapped in faint halos of energy. When matter falls into a black hole, the universe's entropy rises enormously. This makes black holes potent drivers of time's forward flow. Over incomprehensible ages, they evaporate softly through Hawking radiation, releasing their mass into quiet streams of particles. This evaporation cannot be reversed. It is like a whisper drifting away into the night, never to return exactly as it was. Black holes, once the engines of cosmic drama, eventually become symbols of quiet dissolution, their slow fading reinforcing the one-way motion of time. Light itself is another gentle guide. A photon feels almost weightless, yet its journey carries deep meaning. As it moves through expanding space, it stretches, its color dimming from bright blue to soft red to the faintest glow imaginable. Eventually, the photon becomes so stretched that it blends into the background of the universe, like a note fading at the end of a long, peaceful song. This slow transformation makes the directionality of time visible in the soft flow of radiation, drifting into the dark. On quantum scales, time reveals its direction in delicate, nearly invisible ways. A quantum state begins crisp and fragile, like a shimmering pattern on water. When it interacts with the environment, the pattern spreads into countless tiny ripples. These ripples cannot be gathered back into the original state because they now touch more particles than we could ever align. Decoherence, the spreading of quantum information, acts like a gentle breeze pushing the universe forward through time. Even the smallest events contribute to this quiet momentum. Human perception also drifts along with these cosmic rhythms. Our memories settle behind us like glowing footprints in fading light. Each thought forms a new pattern in the brain, shaped by chemical and electrical signals that never reverse themselves. We sense time flowing forward because the physical processes that create awareness follow the same rules as stars cooling and photons stretching. Our minds move with entropy just as the universe does, allowing us to experience time as a soft stream rather than an abrupt sequence. When all of these elements combine, they reveal a universe moving gracefully toward deeper tranquility. Entropy grows like a cloud unfolding in still air. Quantum patterns disperse like faint vibrations in a dream. Light stretches into soft threads. Gravity shapes matter into calm structures that eventually release their stored energy. Expansion carries everything outward with silent patience. Time moves forward because the universe gently chooses ease over tension, diffusion over compression, openness over tightness. The arrow of time is simply the universe relaxing. As we continue drifting through the quiet mystery of time, the universe begins to resemble a gentle dream, a place where everything moves with slow and silent intention. In the vastness of space, faint waves of light glide like soft threads through the calm dark, weaving subtle patterns that whisper of distant stars. Clouds of interstellar dust spread like delicate veils, drifting so slowly that they seem frozen in a peaceful moment. Within this tranquil scenery, time unfolds one breath at a time, guiding matter and energy along a path shaped by quiet laws that never hurry and never reverse. One way to understand this forward motion is to imagine the universe as a slowly cooling tapestry. In the early cosmos, energy pressed tightly together, creating a brilliant glow. Yet over billions of years, this glow stretched into a thin blanket of soft radiation that fills every corner of space. This cooling is not simply a change in temperature, but a transformation in the structure of the cosmos. The universe relaxes into wider and gentler states, and time follows this relaxation. Like warm air dispersing into a cool room, the universe moves calmly from concentrated beginnings towards smoother, more peaceful configurations. Entropy lies at the center of this gentle spreading. Entropy increases because the universe naturally chooses states that are easier to reach, states where energy is more evenly shared and arrangements are more relaxed. Imagine watching driftwood floating in a calm sea. At first, the pieces may hang together, but over time, the water slowly pulls them apart, scattering them across the surface. They do not reassemble on their own. This scattering reflects the quiet inevitability of entropy. Time flows in the same direction as this scattering, following the soft current that carries systems from low entropy beginnings toward more diffuse and peaceful states. Gravity, too, participates in this calm but inevitable shift. When a cloud of cosmic dust gathers under gravity, its movement forms graceful spirals illuminated by starlight. These spirals drift inward like soft breezes curling through the air. Eventually, they form stars, planets, or black holes. Yet even this gathering increases gravitational entropy. The final stages of gravitational collapse, especially the formation of black holes, raise entropy dramatically. A black hole is like a deep well of silence with an event horizon glowing faintly through Hawking radiation. Its slow evaporation over unimaginable time reinforces the arrow of time through the quiet release of energy into the universe. Light provides another gentle clue. A photon begins its journey full of energy, but as it travels through the expanding cosmos, it stretches into longer and softer wavelengths. Its glow becomes dimmer, its color cooler. Eventually, it drifts into the background as a faint whisper of radiation. This stretching cannot be undone because the very fabric of space is expanding like a soft cloth being pulled outward. Time mirrors this expansion, moving forward as the universe opens wider and wider, allowing light to fade into its calmest form. Quantum processes also reveal the arrow of time in soft and delicate ways. A quantum state begins as a shimmering pattern full of potential possibilities. When it interacts with its environment, the pattern spreads outward, dissolving into countless tiny ripples of information. This process, known as decoherence, is like watching ink disperse slowly through water. Once spread, the pattern cannot reconcentrate itself. The loss of coherence shows that even at the smallest scales, the universe prefers expansions over reversals, spreading over tightening, outward motion over inward. Time flows along this spreading path, in harmony with the behavior of quantum fields. The expansion of the universe shapes this flow on the largest scales. Galaxies move apart like glowing islands floating on a gentle tide. The space between them grows. The night sky becomes more spacious, and anything that enters the expanding horizon of the cosmos becomes part of an irreversible unfolding. Expansion provides the canvas on which time paints its one-way motion. As the universe widens, every process within it finds a direction that aligns with this widening, creating a cosmic rhythm that cannot be reversed. Human awareness aligns with these patterns in a natural and tender way. Every memory we form is a trace left on the mind, a gentle imprint that cannot be rewritten backward. Our thoughts drift forward because the physical processes of the brain follow the same entropy-driven patterns as stars cooling or photons stretching. We remember the past because its traces remain, while the future stays hidden because its traces have not yet formed. Our perception glides softly with time, like a small boat carried by a quiet current. When we bring all these elements together, a unified picture emerges. The universe moves forward because everything within it relaxes, stretches, cools, disperses, and spreads. Entropy rises like soft mist drifting through a field. Gravity collapses matter into high entropy structures. Light stretches into long, peaceful waves. Quantum states scatter into delicate patterns. Space expands like a calm breath, expanding a chest. The arrow of time is simply the gentle unfolding of the cosmos itself, guiding everything toward deeper stillness and wider calm. As we drift deeper into the question of why time moves forward, we begin to notice that the universe contains many layers of motion, each one contributing its own quiet influence. Beyond entropy, beyond gravity, beyond the stretching of light, there are other forces and principles that shape the arrow of time in subtle and elegant ways. These forces operate like hidden currents beneath the smooth surface of a deep lake, moving softly yet decisively, guiding reality along a single direction while the cosmos rests in its vast silent expanse. One of these deeper ideas involves the concept of symmetry breaking. At the most fundamental level, the early universe was almost perfectly symmetrical, filled with pure energy distributed evenly like a soft glow suspended in stillness. As the universe expanded, this symmetry began to break. Particles formed, forces separated. Matter and antimatter emerged, but not in equal amounts. These tiny imbalances acted like the first ripples on a sleeping pond. Once symmetry broke, the universe could no longer return to its original state. This early asymmetry becomes one of the roots of the arrow of time, woven into the cosmic fabric from the moment structure began to emerge. Another layer involves the role of cosmic inflation. In the earliest instant after the Big Bang, the universe expanded faster than the speed of light, stretching tiny fluctuations across enormous distances. These faint irregularities later became galaxies, stars, and planets. Inflation transformed the universe into a canvas with a clearly defined direction, like a brushstroke spreading color across an empty page. Once inflation ended, the universe could not contract these stretched patterns back into their original arrangement. This irreversible spreading is another gentle nudge that pushes time forward. We can also explore the arrow of time through the way particles lose energy. A particle in motion moves through space like a quiet spark, gliding across a dark room. But when it interacts with other particles, it shares some of its energy. A collision spreads energy outward in small waves. This diffusion cannot be undone without impossible precision. Each interaction acts like a step in a long path that cannot be walked backward. Over billions of years, these tiny events accumulate into the large-scale direction we call time. A more subtle layer comes from quantum vacuum fluctuations. Even in perfect darkness, space is never truly empty. Tiny flickers appear and vanish, forming momentary pairs of particles that dance in silence for brief moments before fading again. This restless hum gives the universe a slight asymmetry in how energy appears and disappears. While these fluctuations do not determine the arrow of time alone, they contribute a background rhythm that supports the universe's movement toward states where energy is more spread out. Light drifting through this shimmering vacuum gradually loses energy through redshift and cannot regain it. This gentle softness reinforces the forward flow. We can widen the perspective further by considering the role of cosmic boundaries. In physics, the past has a defined boundary, the Big Bang, where conditions were extremely low entropy. The future, however, does not appear to have a boundary at all. Instead, it stretches open like a calm horizon with no visible end. This difference creates an asymmetry in how processes evolve. Systems begin in a narrow, highly organized beginning, and expand into wider, more dispersed futures. Even if each local process can be reversed mathematically, the boundary conditions ensure that the overall evolution moves in one direction, like a wave that has room to spread but nowhere to contract. Another peaceful way to expand the topic involves the flow of information across the cosmos. Information is encoded in the position of particles, the arrangement of dust clouds, the glow of stars, and the ripples of light floating through space. When events occur, information becomes richer and more complex. A supernova leaves patterns of radiation drifting through space. A collapsing cloud leaves turbulence that fades slowly like breath on glass. This information cannot recompress itself into the original simpler state because the universe is expanding and interactions constantly add new layers of detail. The forward flow of time aligns with this growth of cosmic information, guiding the universe from simple beginnings into richer but more diffuse states. A deeper philosophical angle also connects to physics. Some researchers propose that time flows forward because the universe computes its own evolution, step by step. Each moment is a new configuration of matter and energy based on the previous one. This unfolding resembles a slow, dreamlike simulation, where the next frame always follows the last. The computation cannot run in reverse because information spreads and becomes entangled with countless degrees of freedom. The universe calculates forward, not backward. And we drift with this calculation like passengers carried by a soft cosmic tide. Even the large-scale structure of spacetime contributes to the arrow of time. The curvature of space around massive objects guides motion in one direction along geodesics, the natural paths that objects follow. As matter collapses or expands, these paths cannot retrace their shapes perfectly. The geometry stretches and relaxes like fabric shifting beneath gentle pressure. This evolving geometry creates a temporal direction embedded in the shape of spacetime itself. When all these deeper layers combine symmetry breaking, cosmic inflation, energy diffusion, vacuum fluctuations, boundary conditions, information flow, cosmic computation, and space-time geometry, they reveal a universe where time's arrow emerges naturally at every scale. It is not a single cause, but a harmony of gentle processes, each one adding a faint push, each one guiding the cosmos into a wider and softer future. Time moves forward because the universe unfolds like a quiet dream, expanding into deeper silence. As we drift even further into the mystery of time, the universe opens itself like a soft, glowing map where rivers of starlight flow through gentle valleys of darkness. This vast landscape feels suspended in a quiet dream. Light glides in thin silver threads across the silent void, Galaxies settle into shapes that resemble drifting petals. Nebulae float like misty clouds, spreading their colors slowly through the night. Within this hushed panorama, the forward motion of time becomes not only a physical rule, but a calm unfolding of cosmic memory. One of the most fascinating ways to understand time's direction is through the idea of coarse graining. In physics, coarse graining refers to the way we observe systems, not at the particle-by-particle level, but at smooth averages. We see clouds, not individual molecules, stars, not individual atoms. When we look at the universe through this softened lens, small fluctuations disappear into the larger picture. This smoothing creates irreversibility. The fine details that would allow time to run backward get lost. It is like watching waves blend together on a quiet shore. You cannot reconstruct the motion of every droplet, yet the waves keep rolling forward. Coarse graining gives time a gentle push toward the future. Another expansion of the concept comes from the nature of measurement. To measure something, we must interact with it. This interaction leaves an imprint, a tiny shift in the state of the system. These imprints accumulate and cannot be undone. Every measurement leaves a subtle trace that ripples outward like the faint widening circles on a still pond. Because these traces cannot be fully reversed, time gains directionality. The universe remembers its past through these broadened scars of interaction, and this memory softly guides the arrow of time. Cosmic background radiation also reveals a calming aspect of time. This soft glow, stretched thin across the sky, is a memory of the early universe. It drifts through space like a warm echo fading into a cold night. As the universe expands, the radiation cools into longer wavelengths. It cannot rehearse its earlier warmth. It can only drift forward, becoming gentler with each passing age. This cosmic glow acts like the universe's lullaby, whispering the direction of time through its gradual cooling. Another layer lies in particle interactions known as CP, violation. In rare cases, particles and antiparticles do not behave in perfect mirror symmetry. These tiny imbalances play a role in why matter dominates the universe today. They also introduce a microscopic arrow of time buried deep within the foundations of physics. Although this asymmetry is small, its existence hints that the universe has a preferred direction woven into its most fundamental interactions. It is like a faint tilt in the cosmic landscape, encouraging everything to glide gently from past to future. We can also expand our understanding of time by examining how heat flows in the universe. Heat always moves from warmer regions to cooler ones. Even in the most serene corners of space, this rule holds. A warm star radiates outward into the cold vacuum. A cooling planet releases its stored warmth into the night. This flow cannot reverse naturally. Heat does not return to a star once emitted. It continues its soft journey through the emptiness. This one-way path of thermal energy mirrors the direction of time and reinforces its steady drift. Gravitational waves introduce another peaceful angle. When massive objects like black holes or neutron stars move, they create ripples in the fabric of spacetime. These waves glide outward like soft vibrations through a quiet lake. Once emitted, they travel endlessly until they fade into nothingness. They do not reconverge into their original form. They're spreading marks, another irreversible process. The universe fills with these gentle ripples, each one adding a faint contribution to the arrow of time. We can broaden the concept even further through the physics of horizons. Horizons appear not only in expanding space but also around black holes. A horizon hides information. Once information passes behind it, we cannot access it again. This loss creates a deep asymmetry in space and time. The universe cannot return to a previous state because parts of its information disappear behind horizons. The presence of these hidden boundaries adds another quiet layer of direction to time's flow. Human consciousness mirrors these cosmic truths. Our experiences settle behind us like glowing dust floating in dim light. Every moment leaves a trace in the mind, shaped by irreversible biochemical processes. Thoughts spread through neural pathways like soft waves of electricity. Once a thought occurs, it cannot be unthought. Once a memory forms, it cannot be unwritten without leaving a new imprint in its place. Our inner arrow of time is the biological echo of entropy unfolding within the brain. When we bring all these ideas together, coarse graining, measurement traces, cooling radiation, CP violation, heat flow, gravitational waves, cosmic horizons, and human memory, we arrive at a universe filled with gentle but irreversible processes. Each one adds a small push toward the future. Each one softens the path forward. Time moves as a consequence of countless tiny motions, all drifting in harmony toward states of deeper calm and wider stillness. As we drift further into the quiet depths of the cosmos, the question of time's forward flow becomes less like a puzzle to solve and more like a gentle melody woven through the fabric of the universe. Everywhere we look, we find traces of this soft cosmic rhythm. In the silent stretches between galaxies, faint streams of light glide like thin silver ribbons, slowly stretching as they travel. Vast clouds of dust drift like pale feathers scattered across a tranquil sea of darkness. Stars pulse gently, exhaling warmth into the cold, then dimming into silence. Within all these slow motions lies the same subtle force guiding the universe from what was toward what will be. One new way to understand this forward drift comes from the concept of phase space, a mathematical landscape that records every possible state a system can have. Each particle, each motion, each vibration occupies a point in this enormous space. When the universe evolves, these points spread into larger regions. They do not return neatly to their earlier positions. Like a handful of tiny glowing embers tossed into a breeze, they drift outward, filling more space with each gentle movement. This spreading makes the past distinct and the future open, giving time its one-way shape. Another layer appears when we consider how atoms and molecules store energy. When an atom absorbs energy from light, it rises into an excited state, but it never stays there. The energy flows back out as a photon, drifting softly through space. This relaxation process cannot be perfectly reversed. The emitted photon may wander forever, stretching and cooling as it travels. The atom cannot reclaim it. This tiny irreversibility repeats billions of times across the universe, creating a soft chorus of one-way transitions that accumulate into the steady flow of time. The structure of spacetime itself also contributes. According to general relativity, mass and energy bend spacetime into curves. These curves influence how objects move, like soft, invisible hands guiding their paths. But these curves also change as energy moves and matter shifts. The geometry evolves and settles into new shapes. This changing landscape prevents the universe from returning to its earlier arrangement. The curvature of spacetime creates a natural sense of before and after, a subtle asymmetry woven gently into the cosmic fabric. We can also deepen our understanding through the lens of cosmic cooling. As stars burn, they release light and heat into space. This warmth spreads outward, thinning into delicate waves. Once emitted, it cannot be compressed back into the star. Each bit of radiated energy drifts on its own journey, contributing to a universe that gradually cools like a vast furnace settling after a long fire. This cosmic cooling marks the passage of time, like the fading embers of a dream, showing how the universe slowly relaxes into quieter states. Another delicate aspect comes from the phenomenon of irreversibility in biological systems. Although life seems separate from the cosmos, it follows the same thermodynamic rules. The processes that shape memory, growth, thought, and consciousness require energy to flow in one direction. Cells break down complex molecules into simpler ones, releasing energy that cannot easily be reassembled. Even consciousness moves forward through the formation of neural patterns. Like soft chalk brushes leaving marks on a board, each moment of awareness leaves traces that cannot be erased without creating new traces. Biology echoes the arrow of time with each quiet breath and each slowly drifting thought. We can widen our perspective again by reflecting on how structures decay. Cosmic dust grains erode slowly under the soft pressure of radiation. Planetary atmospheres leak atoms into space. Magnetic fields weaken. Orbits shift by tiny amounts. These decays are gentle and almost silent, yet they reveal the universe's tendency to move from structured states into smoother, softer ones. Every decay is a note in the slow symphony of time, each one drifting towards stillness. Another fascinating expansion comes from the study of emergent phenomena. Many properties of time arise not from single particles, but from the combined behavior of many. Just as a flock of birds moves in patterns no single bird controls, time's arrow emerges from the collective calm motion of countless interactions. This emergence is soft and natural. It requires no external push. It is simply the universe following its most graceful path. Finally, we can consider the philosophical idea that the universe is always writing its own story. The past contains written pages filled with the marks of events that already occurred. The future contains blank pages waiting to be shaped. The universe writes on these pages by dispersing energy, forming memories, cooling light, and altering its structure. What has been written cannot be erased without leaving new marks. This cosmic journaling gives time its forward motion, a calm and continuous unfolding of existence. When we bring these ideas together, phase-space spreading, atomic relaxation, space-time curvature, cosmic cooling, biological irreversibility, structural decay, emergent behavior, and the universe's own evolving record, we discover that the arrow of time is not a single mechanism, but a gentle harmony. It is the soft breath of the cosmos, the quiet drift from order toward openness, the slow unwinding of patterns into deeper calm. As we drift deeper into the question of why time moves forward, the universe begins to resemble a serene tapestry woven from threads of light and waves of silence. In the vast calm of space, soft glimmers shimmer like distant fireflies suspended in slow motion. Enormous nebulae unfold like quiet blossoms drifting through the dark. Dust spreads in pale ribbons, gently illuminated by faint starlight. Every motion feels unhurried, as if the cosmos itself breathes in long, peaceful cycles. Within this dreamlike setting, the arrow of time reveals itself not as a force that pushes, but as a direction that emerges naturally from the quiet behavior of the universe. One new way to understand this direction involves the concept of cosmological initial conditions. At the birth of the universe, conditions were extraordinarily special, smooth, and uniform. This smoothness is not an ordinary trait. It is rare and delicate, like a perfectly calm lake before the slightest breeze touches its surface. Because the early universe began in such a low entropy state, it created a vast difference between what was and what could be. Time flows forward because the universe is still unwinding from that initial moment of perfect smoothness, gradually spreading into more relaxed and varied configurations. This connection between the beginning and the flow of time becomes clearer when we examine the idea of increasing complexity. Over billions of years, the universe has formed stars, galaxies, planets, and life. At first, this rising complexity seems opposite to entropy, but in reality, complexity emerges as entropy grows. Patterns form in the same way frost grows on a cold window, expanding with quiet beauty, while heat escapes into the air. The formation of complexity is simply one gentle pathway toward higher entropy. Time moves forward because complexity unfolds naturally, like flowers opening slowly under the soft light of dawn. Another perspective emerges through the study of chaos theory. In chaotic systems, tiny differences in starting conditions lead to enormous differences later on. A tiny vibration, a small change in temperature, a minute shift in position can create entirely new outcomes. This sensitivity means the universe cannot easily retrace its steps. The chaotic interactions of particles, clouds, and light scatter information in all directions, spreading it like glitter poured into a gentle breeze. Once scattered, the universe cannot restore the exact arrangement. This loss of precise structure gives time a clear and irreversible direction. We can also explore the arrow of time through the behavior of fields that permeate space. Electromagnetic fields, gravitational fields, and quantum fields shift like invisible tides. These fields allow waves to propagate in one direction, carrying energy outward in expanding spheres. When a star shines or a particle vibrates, these waves travel endlessly through the cosmos. They do not return to their source. Each wave adds its own small thread to the fabric of cosmic history. Over time, these threads accumulate, creating a rich tapestry of events that defines the past while the future remains open and unshaped. A related idea involves the nature of radiation emitted by accelerating charges. When an electron changes its motion, it radiates energy outward. This radiation forms an electromagnetic wave that travels through space. The energy lost by the electron alters its motion in a way that cannot be reversed perfectly. This process, called radiation damping, is subtle but universal. It happens constantly in the universe, adding another quiet contribution to the arrow of time. Each emitted wave is like a whisper drifting into the distance, marking a moment that cannot happen again. The arrow of time also emerges in the behavior of large-scale cosmic flows. Enormous filaments of matter stretch across the universe, forming vast structures shaped by gravity and motion. These filaments evolve as matter flows along them toward galaxy clusters. This flow resembles slow rivers of dust and gas, moving through a silent canyon of stars. Matter drifts inward along gravitational gradients, and this drifting cannot be reversed without enormous changes in the energy of the system. These cosmic rivers give time a direction defined by gravitational motion and relaxation. A new angle appears when we consider the thermodynamic arrow in living systems. Life depends on gradients of energy. Plants gather sunlight and convert it into stored chemical energy. Animals consume this stored energy and release heat into their surroundings. These processes rely on the movement of energy from concentrated to dispersed states. This energy flow aligns life with the forward arrow of time. Biological structures, from cells to entire ecosystems, rely on irreversibility. Every action, every heartbeat, every breath follows the same path as stars cooling and galaxies spreading. Another profound element is the universe's gradual transition toward equilibrium. Over extremely long timescales, the cosmos trends toward a state where energy is distributed smoothly. Galaxies drift apart, stars fade, light stretches, matter cools. This approach to equilibrium is gentle and inevitable, like a soft blanket settling over a quiet landscape. Time flows forward because the universe moves toward this peaceful stillness, a final state in which no differences remain to drive motion or change. We can even expand further into the conceptual idea that time's arrow reflects our limited perspective. Humans perceive time through memory and expectation. We remember what has happened because physical traces remain. We cannot see the future because its traces do not exist. Our consciousness, therefore, experiences time as flowing forward through a landscape of events that accumulate behind us. This psychological arrow mirrors the physical arrow, not by defining it, but by aligning naturally with the irreversibility embedded in cosmic processes. When these new layers come together, initial conditions, complexity, chaos, field dynamics, radiation damping, cosmic flows, biological gradients, equilibrium, and perception, they form a broad and harmonious picture. Time moves forward because the universe expands into deeper calm, richer diversity, and wider diffusion. The arrow of time is not a rigid rule. It is the gentle unfolding of a universe that drifts from tight beginnings toward open horizons, carrying every star, every photon, and every memory along with it. As we drift further into the serene mystery of time, the universe begins to look like a soft field of glowing patterns, gently shifting in the silence of cosmic night. In the vast stretches between stars, faint shimmering filaments drift like strands of silver thread carried by a calm celestial wind. Galaxies lie scattered across the darkness like clusters of soft petals drifting slowly on a quiet pond. Everything seems to move with a patient grace, and within this gentle choreography, the arrow of time emerges like a delicate current flowing through an endless dream. One new way to understand this forward flow involves the concept of energy landscapes. In physics, systems move from states of high energy toward states of lower energy, sliding down smooth curves like snowflakes gliding along a gentle slope. Once they settle into lower valleys, they cannot spontaneously climb back to their earlier positions without new energy being added. This downward drift shapes an irreversible path. The universe itself travels across a vast energy landscape, descending softly from its initial high energy state into calmer regions. Time follows this descent, tracing the slow slide of the cosmos toward deeper rest. Another layer appears when we consider the role of cosmic turbulence. In the early universe, matter swirled in chaotic currents, forming eddies that stretched across enormous distances. Over billions of years, these turbulent motions settled, leaving behind the calm, large-scale structures we see today. Turbulence dissipates energy into heat, spreading it thinly through space like warm breath fading in cold air. The dissipation is irreversible. Once the chaotic motions quiet, the energy they carried disperses forever. Time flows in the direction of this dissipation, guided by the universe's gradual calming of its once restless motions. We can also expand the topic by looking at the smoothing effect of collisions. When particles collide, they exchange energy in ways that erase memory of their previous paths. After many collisions, their motions become more random, blending into a soft, statistical dance. These random patterns cannot be reversed without knowing the exact details of every collision. Because this perfect knowledge is impossible, the system spreads into more probable configurations. Time moves forward because each collision leaves a tiny mark of irreversibility, a small but permanent reshuffling of cosmic motion. Another fascinating element involves the behavior of quantum entanglement. When two particles become entangled, they share a connection that links their states no matter how far apart they drift. But entanglement is delicate. Once it interacts with the environment, the entangled state dissolves, spreading its information into countless degrees of freedom. This spreading cannot be gathered back. It is like a drop of dye dispersing into a still pool. The loss of entanglement creates a microscopic arrow of time, adding another quiet strand to the universe's forward flow. Cosmic expansion adds yet another peaceful dimension. As space stretches, galaxies drift apart in slow, graceful motions. The expansion acts like a calm tide drawing everything outward. This widening creates room for entropy to grow and ensures that energy spreads into broader regions. Because the expansion cannot reverse itself under current physical laws, time follows its direction. The universe gently opens, and time opens with it, like two wings unfolding together. We can deepen the picture with the concept of retarded potentials in electromagnetism. When a charge moves, it creates disturbances in the electromagnetic field. These disturbances do not propagate backward in time. They travel outward only into the future. This is why we see the effects of past motions but not future ones. The electromagnetic field carries a built-in arrow of time, woven into the way radiation spreads across space. Each wave moves outward like a ripple on a pond, always expanding, never converging back into a perfect point. Another angle involves the tendency of physical processes to erase fine detail. Fine detail contains information about the past. As processes evolve, they blur this detail into broader patterns. Heat spreads, light diffuses, vibrations fade. This blurring is irreversible because it requires too much precision to reverse the spreading. The universe forgets its sharp beginnings and moves gently into softer, more uniform states. Time flows in the direction of forgetting, not remembering, expanding its reach as information becomes more diffuse. Biological systems reveal similar rhythms. A seed germinates, grows, and eventually releases new seeds. Each stage leaves traces that cannot be reversed. A living being grows older because its cells follow biochemical reactions that move in one direction. These reactions rely on gradients of energy that slowly dissipate. Life is a small but vivid mirror of cosmic irreversibility. Even the act of dreaming reflects this direction. Thoughts drift like soft clouds unfolding in the mind. Once experienced, they cannot be reversed. Consciousness glides gently with time, following the same thermodynamic rules as the stars. Finally, we can look at the deep idea that the universe is always increasing its informational complexity. Even as entropy grows, the patterns of particles and fields become richer and more interwoven. This complexity grows in one direction, like a tapestry slowly gaining new threads. Each interaction adds to the universe's story. Once woven, the stories cannot be undone. This accumulation of cosmic events creates a forward-moving narrative, guiding time along a path defined by memory, change, and gentle unfolding. When all these elements, energy landscapes, turbulence dissipation, collision smoothing, entanglement decay, expansion, radiation flow, detail erasure, biological directionality, and informational growth come together, they reveal a tapestry of quiet irreversibility. Time moves forward because everything in the universe follows pathways of soft settling, graceful spreading, and unfolding structure. The arrow of time is the cosmos, drifting from tension into stillness, from tight beginnings into wide, quiet horizons. As we continue drifting through the quiet expanse of the cosmos, the flow of time begins to feel like a gentle tide moving through a vast and silent ocean. In the darkness stretching between galaxies, faint dust settles like soft snow drifting through an endless night. Light travels in thin golden threads that glide peacefully through the void, slowly stretching into longer waves as the universe expands. Stars flicker like distant embers floating on a calm breeze. Within this tranquil setting, the arrow of time emerges as a delicate guiding current, carrying the universe from youthful brilliance toward deeper stillness. One new perspective on this forward motion involves the idea of attractor states in dynamical systems. Many complex systems naturally evolve towards certain stable configurations, like a ball rolling into a valley or a drop of water sliding down a window. Once they reach these states, they tend to remain there. The universe contains countless such attractors. Particles settle into energy levels. Planets settle into stable orbits. Galaxies settle into swirling spirals. These attractors shape a one-way journey through time because systems rarely climb back to earlier, more unstable states without outside energy. The descent into stability creates a soft, irreversible flow. Another layer emerges when we explore the behavior of chemical reactions. Every chemical process releases or absorbs energy, and these energy changes often cascade into the environment. A molecule rearranging its electrons emits photons that drift through space. Heat spreads into surrounding atoms. Once these changes occur, the original arrangement cannot return without new input. Chemistry, therefore, becomes one of the universe's storytellers, writing irreversible steps into the cosmic script, each reaction a tiny push that carries time forward. We can expand further by examining the physics of dissipation in mechanical systems. When an object vibrates, spins, or oscillates, it gradually loses energy to its surroundings. A bell rung in the quiet night softens into stillness. A planet's rotation slows as tidal forces steal its energy. These dissipative processes leave irreversible fingerprints across the universe. Once lost, mechanical energy does not spontaneously reconcentrate itself. It returns only as low-grade heat drifting through space. This slow calming of motion aligns perfectly with the arrow of time. Another subtle idea involves the nature of cosmological horizons. As the universe expands, some regions recede from us faster than light due to the stretching of space. Their light will never reach us again. These regions slip permanently out of contact like ships sailing beyond an unreachable horizon. This loss of causal connection carves an irreversible structure into spacetime. The universe becomes divided into what can influence us and what can never return. Time flows forward along the boundary of what is visible and what is fading away, creating a soft asymmetry in the cosmic landscape. A deeper perspective appears when we consider how matter transitions between states. When ice melts into water or water evaporates into vapor, the transformation follows a thermodynamic arrow. Molecules move into configurations that require less constraint, sliding from rigid structures into freer ones. These transitions spread energy and cannot be reversed without new work being applied. Even on cosmic scales, matter changes state. Stars fuse hydrogen into helium. Supernovae scatter heavy elements across the galaxy. Each transformation marks a step in the universe's path toward wider diversity and greater entropy. Quantum field fluctuations also play a role. Space is filled with vibrating fields that fluctuate constantly like faint ripples on a sleeping lake. These fluctuations create an asymmetry between the vacuum energy of the past and the vacuum energy of the future. As the universe expands, vacuum energy grows in relative influence, shaping the acceleration of cosmic expansion. This shifting balance sets a direction for cosmic evolution. Time follows the quiet rise of vacuum dominance, drifting toward an era where the expansion becomes ever more gentle and pervasive. A beautiful new angle comes from the study of wave interference. Waves overlapping in a medium create patterns that often fade as energy distributes through the system. Constructive and destructive interference blend into smooth averages over time. Once these patterns blur, they cannot be sharpened back into their original arrangement. This smoothing effect appears everywhere from sound waves to gravitational waves to quantum wave functions. The universe's tendency to blur fine patterns into gentle gradients reinforces the soft, irreversible flow of time. Life itself offers another expansion of the concept. Biological growth relies on the consumption of ordered energy and the release of disordered energy. A plant gathers sunlight, then spreads heat into the environment. A living cell uses chemical gradients to power actions that leave irreversible traces. These processes follow a one-way path, each step dependent on the previous one. Life cannot run backward because its chemistry is tied to the larger thermodynamic arrow. The evolution of living systems becomes a quiet echo of the universe's own irreversibility. Finally, we can explore how the universe gradually simplifies through large-scale decay. Stars burn their fuel. Orbits expand. Magnetic fields weaken. Cosmic structures relax. Over unimaginable time, the universe releases the tension held since its beginning. This relaxation is gentle, graceful, and irreversible, like a giant sigh released across galaxies. Time flows forward because the cosmos continually moves toward equilibrium, unfolding into deeper calmness with each passing age. When we weave these ideas together, attractor states, chemical irreversibility, mechanical dissipation, cosmic horizons, matter state transitions, quantum fluctuations, wave smoothing, biological necessity, and large-scale decay, we see a rich and harmonious picture. The arrow of time emerges from countless soft processes that guide the universe toward openness and serenity. Time moves forward because the cosmos gently unwinds itself, drifting from brilliance into quiet expansion, from tension into silent rest. As we continue drifting through the calm architecture of the universe, the forward flow of time begins to resemble a gentle wind moving across an endless landscape of stars. In the soft darkness between galaxies, faint streams of light drift in long, shimmering lines. Nebulae spread like pastel clouds, slowly unfolding into delicate shapes. Dust settles in soft veils that sway through cosmic silence. Everything seems to move with a slow rhythm, as if the universe is breathing in long, quiet intervals. Within this serene dance, the arrow of time emerges as a subtle direction guiding every pattern into deeper calm. A new perspective on this direction involves the concept of information asymmetry. In physics, information is encoded in the arrangement of particles, the energy they carry, and the patterns they form. When events unfold, information spreads through the environment, like ripples moving across a still lake. Once dispersed, this information cannot be squeezed back into its original form without impossible precision. A shattered pattern cannot unshatter. A scattered cloud cannot spontaneously gather into the exact shape it once had. This one-way spreading of information creates a quiet but powerful engine for the flow of time. Another fresh idea arises from the behavior of fractal patterns in nature. Fractals unfold through repeated steps, each iteration adding new layers of detail. These patterns evolve forward because each step depends on the previous one. They cannot be reversed without erasing the structure they have built. In the universe, fractal-like formations appear in galaxy clusters, clouds of dust, river-like filaments of dark matter, and even in the branching structures of lightning. These structures grow outward, never inward, marking a natural direction. The universe expands its fractal signatures into the future, not the past. We can also widen our view by examining the arrow of time through the formation of cosmic shells. When stars explode, their outer layers sweep outward in vast, luminous waves. These shells move through space like expanding rings on a gentle pond. They carry heavy elements that become part of new stars and planets. The shells do not collapse back into the star that produced them. This outward motion is irreversible. Supernova remnants drift forward through time, carrying the memory of stellar death into the future, enriching the cosmos with new material. Another delicate angle comes from the behavior of sound waves and vibrations in cosmic environments. When waves travel through interstellar gas or planetary atmospheres, their energy spreads and their patterns soften. Sharp tones blur into broader resonances. Once blurred, the original sound cannot be perfectly restored. This natural smoothing introduces another layer of irreversibility. Time flows with the soft loss of sharpness, just as ripples fade on a pond long after the initial disturbance has passed. We can deepen the concept by exploring how order emerges from quantum fluctuations. In the earliest universe, tiny fluctuations in density served as seeds for the formation of large structures. These fluctuations were random, but once amplified by cosmic expansion, they created unique patterns that set the stage for everything that followed. These patterns represent a frozen record of quantum randomness. The universe cannot rewind these fluctuations because they have already shaped galaxies and stars. These imprinted irregularities guide time forward by defining an irreversible starting point. A further layer involves the behavior of thermal gradients. In nature, energy flows spontaneously from regions of high temperature to low temperature. This flow shapes everything from the burning of stars to the melting of ice to the movement of heat through planetary atmospheres. Thermal gradients always relax toward equilibrium. This relaxation cannot reverse without external work. The universe follows this gentle settling process across all scales, and the arrow of time aligns with this slow smoothing of temperature differences. Electromagnetic radiation offers another quiet clue. When charged particles accelerate, they emit radiation that carries momentum and energy away. This radiation travels outward into the universe and cannot be reabsorbed exactly as it was released. The emission leaves the source changed forever, setting a clear before and after. The flow of radiation draws a soft line across time, marking the path from energetic beginnings to calm endings. Biological evolution gives yet another expansion to the concept. Life adapts, learns, remembers, and transforms through processes that depend on past events. Genetic information accumulates through irreversible mutations. Ecosystems shift through cycles that cannot retrace their exact steps. Evolution creates a record written into the DNA of every living being. This record extends only forward through time. The universe mirrors this biological arrow through its own accumulation of structure and information. A profound idea also emerges from mathematical models of entropy production. Many natural systems generate entropy not in uniform ways but in bursts. These bursts resemble gentle storms of reorganization, where old structures dissolve and new ones emerge. These transitions are inherently directional, like leaves falling in autumn or waves breaking on a shore. They symbolize the universe's continuous passage from one moment to the next, each burst nudging time forward. Finally, we can consider the large-scale drift of galaxies. Gravity pulls galaxies into clusters, but the expansion of space pulls them apart. This dual motion creates a complex dance of attraction and separation. Over time, the separation dominates. Galaxies move farther away from each other, and their light stretches into faint whispers. This slow, cosmic drifting creates a directionality written directly into spacetime. The future grows more spacious, while the past remains tightly compacted. When these new layers information asymmetry, fractal growth, supernova expansion, wave smoothing, quantum seeds, thermal gradients, radiation loss, biological evolution, entropy bursts, and galactic drift join together, they form a deep and harmonious portrait of time. The arrow of time is not one cause, but a constellation of gentle processes moving the universe toward broader, softer, and more open configurations. Time moves forward because the cosmos flows naturally into greater calm, wider space, and deeper silence. As we drift deeper into the silent architecture of the cosmos, the flow of time begins to resemble a gentle current moving through a wide and tranquil ocean. Light drifts in long golden filaments, stretching softly across the void. Dust clouds settle in pale cotton-like layers, illuminated by the faint glow of distant suns. Galaxies hang in the quiet darkness like luminous lanterns suspended in slow motion. Everything seems to glide forward with a calm and patient rhythm. And within this peaceful motion, the arrow of time reveals itself as a subtle path guiding every cosmic transformation. One new perspective arises from the study of symmetry and its breaking over time. In the early universe, many physical laws held perfect symmetries, like an untouched sheet of water reflecting the sky. But as the universe expanded, these delicate symmetries fractured. Particles formed, forces separated, energy arranged itself in new ways. Each broken symmetry introduced an irreversible step, a moment the universe could not revisit. These fractures act like gentle cracks in a frozen lake, spreading outward and marking the direction in which the cosmic story unfolds. Another layer emerges when we consider the principle of least action. In physics, systems follow the path of least resistance, choosing the route that requires the least effort. These paths naturally favor forward evolution because they minimize energy expenditure. A particle moves along a trajectory where the sum of motions is simplest. Light follows geodesics that bend gracefully through curved spacetime. Once these paths are chosen, the system cannot unchoose them without extra energy. The universe follows these natural lines like soft trails through a field of stars, and time moves with the same quiet inevitability. We can broaden the view through the concept of decoherent histories. In quantum mechanics, reality unfolds through many potential branches, But only some of these branches stabilize into classical events. These stable paths form coherent histories that stretch forward, not backward. The universe selects these stable timelines because they produce consistent patterns. Once a history forms, it becomes part of a chain that cannot be undone. This branching process resembles the slow unfolding of a great cosmic tree, its branches growing outward through time, never inward. Another subtle idea involves the dissipation of structure in gravitational systems. Star clusters gradually lose their tight organization as interactions scatter their stars into more diffuse arrangements. Orbits stretch, energy spreads, clusters relax into softer shapes. This relaxation cannot be reversed because each interaction leaves behind permanent shifts in velocity and position. Over billions of years, these shifts accumulate into the quiet expansion of structures. The way gravity softens its own creations becomes another peaceful signature of time's direction. A fascinating new angle appears in the context of cosmic shear. As light travels through the universe, it encounters massive structures that distort spacetime. These distortions stretch and twist the light into new patterns, creating gentle warps across its path. Once light undergoes gravitational lensing, the deformation becomes part of its journey. The universe cannot unscramble the warped patterns without reversing cosmic expansion and mass distribution. Each warped ray of light carries the imprint of time's movement, like a soft fingerprint on a shimmering thread. We can expand further by examining how entropy unfolds in systems driven far from equilibrium. When energy flows through a system, it creates organized structures like convection patterns, chemical gradients, or magnetic domains. But these structures form only while energy flows. Once the flow weakens, the patterns dissolve into simpler configurations. This dissolution marks the irreversible march toward equilibrium. These temporary structures are like ripples on a quiet lake, forming briefly then fading into smoothness. Time flows with their rise and fall, defining a rhythm that echoes across cosmic and biological scales. Another beautiful perspective involves the cosmic cycle of light absorption and emission. Dust grains absorb starlight, warm slightly, and re-emit that energy as infrared radiation. This radiation drifts outward into the universe in soft, stretched waves. Once emitted, these gentle waves cannot be returned to their exact state. The cycle of warming and cooling spreads energy widely, adding another subtle step to the arrow of time. Like breaths taken by the universe, these thermal exchanges reveal the quiet progression from concentrated warmth to widespread stillness. We can deepen our understanding through the phenomenon of particle decay. Many particles are unstable and transform into lighter particles over time. A neutron decays into a proton, electron, and neutrino. Heavy particles break into smaller fragments. This decay is irreversible because it moves from high-energy structures to lower-energy ones. Each transformation is a tiny step along a path carved by the arrow of time. Across billions of years, the slow decay of particles shapes the universe's evolution, guiding it gently towards simplicity. Another profound idea comes from the loss of phase relations in large systems. Waves and particles carry phase information that determines how they interfere. But interactions with the environment blur these phases, destroying the delicate patterns. Once blurred, the patterns cannot be restored. This fading of phase coherence marks a transition from reversible quantum motion to classical irreversibility. It is like watching intricate frost patterns soften and melt under gentle sunlight. The transition carries time forward with a serene and unhurried grace. Finally, we can examine the cosmic flow of order itself. Structures rise from randomness, then dissolve back into randomness at higher entropy. Stars ignite from chaotic clouds, burn with structured brilliance, then fade into dispersed ash. Planets form, stabilize, and eventually cool. Even galaxies evolve through stages of growth and quiet settling. This cyclic but directional evolution resembles a grand unfolding, like a vast canvas being painted from left to right. Time simply follows the direction of this cosmic brushstroke. When these new layers symmetry breaking, least action paths, decoherent histories, gravitational relaxation, cosmic shear, non-equilibrium structures, radiative cycles, particle decay, phase loss, and structural evolution combine, we see a universe gently guided by countless quiet transitions. Time moves forward because every pattern, every wave, every structure drifts from tension into softness, from concentration into openness, from order into tranquility. The arrow of time is the universe dreaming itself into wider calm.